Hey guys, David here and welcome to this video. So behind me I have three very popular printers, the Ender 3, the CR-10 and the Prusa i3 Mark III. And today I'm gonna look at all their features, compare them and look which one prints the best. Before we get started, a quick disclaimer: Banggood did send over the Ender 3 for review and you can check it out at the link below, but they didn't pay me in any way to say anything good about it, so it's going to be still completely objective. The other two, the CR-10 and the Prusa i3, were bought by me. The CR-10 also isn't really stock anymore and already has quite a few hundred print hours on it, so the print results might be a little bit different than what you get out of the box. But I think it should still kind of represent what it can do. So before we get into the meat of the potatoes, let's start off with some overviews of the features that these different printers offer. Now, the price points of these printers are very drastically different. The Ender 3 comes in at under $200, while the CR-10 is sub $400, depends on how much it is on sale, and the Prusa i3 costs around $750 before taxes. So there is quite a big difference, and for that price you would really hope that the Prusa i3 prints a lot better than the Ender 3. But mainly what the Prusa i3 has is a lot more features. Both the Ender 3 and the CR-10, they're very similar in most features. They both don't have auto bed leveling, they don't have filament runout sensors and fancy stuff like that, but what they do have is a nice heated bed that works. They have a alright extruder, which is Bowden style compared to the direct drive of the Prusa i3. And the Ender 3 also does have power recover. I didn't test that, but supposedly when you turn off, like when you have a power outage, the Ender 3 will remember where it is and can resume the print afterwards, while the CR-10 does not have that functionality. Some extra features that the Prusa i3 has is that it has a genuine E3D hot end that is all metal, so you can go up to higher temperatures. It also has a bed leveling sensor, and it has a filament runout sensor, and it also has really quite dynamic drivers that can detect some things like skipped steps and stuff like that. So it has a lot more smart features. But the interface, again, on all three of them is very similar. It comes with a version of Marlin, and on the CR-10 I actually flashed my own version of Marlin onto it because it did some changes. But it works. It's nothing fancy, no fancy touchscreens or anything, just a dial and a very simple screen. The big difference between some of these printers is the build volume though. The Ender 3 and the Prusa i3, they both have very similar print volumes at around a bit over 20 centimeters cubed. The CR-10, however, has a much larger build volume at 30 by 30 by 40 centimeters. That it really is its biggest distinguishing feature between the other two, and that's also, in my opinion, the only thing that makes it worth over the Ender 3. Because other than the bigger build volume, the Ender 3 and the CR-10 are virtually identical. They have the exactly same hot end and extruder, they have the same electronics, almost the same electronics. The mainboard is ever so slightly different. The build style is very similar, so there aren't many differences there. But for that build size, the CR-10 really is pretty much the cheapest option you get out there. I also did a quick test how far the heated beds can heat up and how quickly they can do that. On the Ender 3 I was really surprised, as the printed bed got all the way up to like 123 degrees Celsius, which is very good. That means you can also print stuff like ABS on it. And it took around 15 minutes to reach that temperature. The Prusa i3 also gets up to around 120, where it is software limited. It might be able to go higher, but in the Marlin firmware you can't go higher than that. And it took around 10 minutes to reach that. And the heated bed temperature is kind of the biggest downside of the CR-10. It was only able to reach 80 degrees Celsius, and it took almost 20 minutes for that. So you're not going to be printing a lot of ABS with the CR-10. But that also is kind of understandable since the print bed is so huge, so it doesn't get quite as hot. But for stuff like PLA and maybe also PETG and stuff like that, it's perfectly fine. The extruder was able to reach the software limit in all the cases, which is 260 degrees for the CR-10 and the Ender 3, as they have a PTFE lined hot end, while the Prusa i3 was able to get up to 295. So let's move on to the second category. I actually made this handle little spreadsheet here with all the different things that I noted down. And the second category I named convenience. And this is basically how easy are the printers to use. That starts from when you take it out of the package, how much do you have to assemble them, how easy are the instructions, continuing with are there good slicer profiles, and how easy are they to use. And in that department, the Prusa i3 takes a big win. Now, it is the one that takes the longest to assemble since you have to assemble every little part, but the instructions are just magnificent. It is a really thick printed color book that has very detailed steps. So basically, if you've ever assembled a Lego set, assembling that printer is basically the same. And if this really nice printed book isn't enough for you, they also have detailed tutorials online, and you can ask their premium support anytime, which is very good. It even comes with a handbook for 3D printing that details a lot of steps beyond after just assembling it. And even I, after 5 years of printing, learned quite a bit reading that handbook. The CR-10 comes in a second place here because it just didn't require much assembly at all. The instructions were virtually non-existent. There were some on the SD card, but pretty bad. But you also didn't really need it. You just had to pretty much attach the upper frame to the lower frame and plug in the cables, which were labeled. So that's no big deal at all. The Ender 3 had a little bit more assembly, also came with a printed sheet that needed quite a lot of interpretation though. So if you've never assembled a 3D printer before, you're probably gonna end up on YouTube finding a tutorial on how to assemble the Ender 3. But after that, it works fine as well. In terms of slicer profiles, in the new Secure version, there are profiles for the Ender 3 and the CR-10, which are quite good as a starting point. And the Prusa i3 Mark III actually comes with its own Slick 3R version that is very good. You just plug in the model, you use one of the pre-made slicer profiles, and it just works. You can also change it up, and there are Cure profiles that they are working on. But I mean, I don't really see any reason not to use the Slick 3R version. And if you're more of a beginner, they even have a much simpler version where you really can just plop it in, select your quality level, and it works. And they call that Prusa Control. And in all three cases, you just export the G-code onto an SD card, which you plug into the printer, and then start the print from the printer. The i3 is using a full-size SD card, which is much better in my opinion than the micro SD card. I actually added an adapter to the CR-10 so I can also use full-size SD cards, as these tiny little things, they're just so easy to lose and really fiddly. And then while they are printing, these two Chinese machines, they both had the same problem. They are just really loud. That's because they're just using just general old stepper drivers, which aren't the smoothest. You can cut down on the noise a lot by adding vibration dampening feet. That's like the first thing I would do when I get these printers. And then you still have the fans, which are kind of loud, but they're acceptable. The Prusa i3 on the other hand is just super nice and quiet. In normal mode, it is a little bit quieter than the two Chinese machines, but when you put it into stealth mode, then it is really just, you can easily just have it running in the background. I could probably even run it right now while recording this video, and it wouldn't be that annoying at all. Alright, and with that done, let's get to the most important category, the print quality. That basically is why you buy your printer, isn't it? All these features are nice and handy, but if it doesn't print well, there's no reason in buying it. And I do have to say that with all three of these printers, I'm really impressed with the print quality. Especially on the Ender 3, since it costs half as much or even like a quarter as much as the other printers. And for that money, it prints absolutely magnificent. I printed these test pieces here that have a whole bunch of different tests. It has a bridging test, it has overhang tests, it has fine tower tests, it also has dimension accuracy tests. So these things that I looked at are in no particular order. But let's start off with C inaccuracies. What I mean by that are little horizontal lines that are caused by the Z-axis not moving up exactly the same amount every time. On the Ender 3, this was mostly good, but there was one line through the print, which I don't know why it is there, it's kind of an anomaly, but I do have to mention it. There's this one line, which is probably caused by something in the Z-axis, but other than that, there are no major issues with the Z-axis. The Prusa i3 is also really good in that department. Only on very thin structures you can see some quite noticeable differences. But that doesn't necessarily have to do with that. It can also have something to do with extrusion and all that stuff. And on the CR-10 here, there are some minor lines, and that might be because of it just kind of is not all that sharp anymore. I might have to like retighten some stuff and grease it up again, but it is also mostly good. Then speaking of thin structures, these are really actually kind of hard to print. So the Prusa i3 actually had almost the most problems with them, and depending on where exactly it was, they turned out very different in width, and there was quite a bit of stringing on those. The Ender 3 did those by far the best, and they are really nice and consistent with only minimal amounts of stringing. The CR-10 had a little bit more stringing, but other than that, printed them beautifully as well. Then looking at text, I divided that into two categories. One text that is horizontal and text that is vertical. On horizontal text, the Prusa i3 walked away with the crown no problem at all. It just is by far the sharpest with only very minor issues, and it just is by far the most legible one. The CR-10 really turned out very bad in that regard. It might have something to do with my extruder and hot end not being quite that good anymore, and it's slightly over extruding, so I wouldn't say that it's too much due to the CR-10, but also a bit due to user error. But the horizontal text was almost not legible at all with the CR-10. The Ender 3 was quite a bit better, but not as good as the Prusa i3. Vertical text was a lot better in all three cases. The Prusa i3 was really good. There were some little strings inside, but other than that, it's really nice and sharp. The Ender 3 also prints very sharp with a little bit less stringing. And on the CR-10, there is one issue that I haven't noticed on any of the other printers really, and that is ghosting. What ghosting is basically if there is a direction change, like if the hot end comes here and then changes direction down, it just overshoots a little and then corrects, and there are like a little bit of wavy lines. That is especially noticeable in text, as it has to change the direction a lot of times there. And this ghosting makes it really hard to read the text on the CR-10. That is likely because it just has a lot more mass in the big bed, and maybe the belts aren't quite as tight as they should be anymore. Then let's look at the top layer. That basically is how well is the infill printed on the very top layer of your print. That in some cases is very noticeable, as that is the part of the print that you can actually see. On the Prusa i3, the stock profiles work absolutely beautiful for that. It is pretty much perfectly extruded and there are no artifacts whatsoever. On the Ender 3, it is also good from the extrusion levels, but there were some little tiny blobs here and there, which are no issue at all to remove, but just something to note. The CR-10 there is also okay, but again there is a slight bit of over extrusion. And also, again, those little tiny blobs that you can remove very easily. Then I already touched at stringing, which in this case the Ender 3 surprisingly takes the crown for that. It works the best out of the box. I haven't tuned stringing much on any of these printers, but on the Ender 3 there's only very minimal stringing that can be easily removed, while on the Prusa i3 there is a little bit more stringing. It's only just very tiny fuzzies, but they are quite a bit more noticeable. Luckily these can be, with just a heat gun, in 2 seconds can be removed, but it still is something to note. They might be able to tune that a little bit more, but it just is there, kind of. The CR-10 is also okay in that regard. There are some tiny bit of stringing, but it's not that bad in any of these printers. The bridging performance on these printers also is very impressive. That just goes to say that all 3 of those have a very good part cooling fan. The Prusa i3 did the best in this regard, as it has a very powerful part cooling fan, and even the longest bridge shows almost no sagging at all, which is quite impressive actually. And both the CR-10 and the Ender 3 only show very minimal sagging in the longest bridge. And similar to bridging overhangs, but they are distinctly different in that they just go out into nothing and have nowhere to attach. And overhangs were rather similar on all of them. Up to 60-degree overhangs was perfectly fine, there's no noticeable depreciation in quality. And then depending on the printer, in the case of the Ender 3, it is okay till about 70 degrees. After that it just completely falls apart. While on the CR-10 and on the Prusa it is okay till about 75 degrees. But after that you either have to clean up after you print with a file or some side cutters, or you have to use support structures. Then I also tested the dimensional accuracy of these printers. For that I just took some calipers and measured the different test portions on this print that were labeled. And this is the setting that has to do a lot with how well your extrusion multiplier is tuned. So they are quite a bit more off on the CR-10, but adjusting the extrusion multiplier a little bit down will tremendously increase the accuracy in that regard. So hole diameter on the Prusa i3 were only very minorly undersized. Those are these 3 holes here. And the slots, on the other hand, down here, they were all perfectly on point, so nothing to complain there. You can basically use the standard profiles, just how they are out of the box for dimensionally accurate parts. Both the Ender 3 and the CR-10, they have the holes a little bit more undersized, meaning that instead of the holes being like that, they're just a little bit smaller. That is because they maybe push out a bit too much material. You can adjust that by under extruding ever so slightly, which then will yield better dimensional accuracy, but maybe less strength. Across the board with holes it's about 0.1 millimeters that it is undersized, and the slots were also about between 0.05 and 0.1. Another other thing that I measured, that I don't actually know the correct term for it, but I'll just call them Mickey Mouse corners. It's a little bit related to ringing, but it basically is the corners. They usually aren't perfect 90-degree corners, but it just overshoots a little bit, and there's kind of a bit like a Mickey Mouse ear there. So I measured how big that overshoot is, and on the Ender 3 and the Prusa i3 it was about 0.1 millimeter that it overshot there, while surprisingly the CR-10 is the best with only 0.05 millimeters there, which is very surprising since the ringing performance on the CR-10 is the worst. So that is it, these 3 printers compared in detail. I did quite a few prints on all of them to just kind of look at it and I think they are all really good printers at their price point, but the Ender 3 is just blowing me away. What you can get for under $200 is just amazing. When I got started in 3D printing, my first printer was a Valmont K8200. It cost around $600 and it printed like absolute trash. Like the CR-10 on a very bad day with this eyes closed could easily beat that. And the Ender 3 just walks all over it. So in these 5 years, the printers have really come a very, very far way. So that is very nice to see. And the CR-10 almost kind of disappoints me a little bit in that regard, but it just goes to show that if you don't need the bigger build volume of the CR-10, there's no reason not to go with the Ender 3 over the CR-10, as the bigger build volume is basically the only advantage that the CR-10 has in my eyes. And then the Prusa i3 is kind of in a different league. While the print results are very comparable to the Ender 3, it just has a lot of convenience features. It is much more enjoyable to have the Prusa running next to you, as it is very quiet. It just works. When the filament runs out, it just stops and you put in a new filament. I actually used that more than once already. And it also just is the most reliable. I just don't even worry about slicer settings, put my STL file into the slicer, slice it with the standard settings, put it on the SD card and just not even worry about it. I don't even have to watch the first layer. I just know that after the time that is set on the screen, it's going to be done and it's going to be just like I want it. So I'm going to have links to all three of these printers, but especially the Ender 3 from Banggood down in the description that you can check out. So if you have any other questions, leave them down in the comments and I will try to answer them. And if you want to follow me, what I'm doing, you can check out my social media accounts, that link down below. And thanks for watching, and until next time.